All right. Welcome to this Urbit developer call. As Paul Simon and Art Garfunkel sang, April comes she will, and in these mellow days our thoughts turn more and more to Borgesian intersections with our daily life. To that end, I'm pleased to introduce today's developer from the Uqbar blockchain project, hodzod-walrus of eponymous fame. Hello, Hodzod.
Hi, how's it going?
Pretty great. So to start us off, tell us a little bit about your background and then what Uqbar is supposed to do. It's kind of been this project that's been shrouded in mystery. There's been a lot of rumors about the skunk works that's been built and is developing this
Yeah, yeah. We got started around November of last year. So Ukbar is, I think most people know, it's a cryptocurrency that we're building on top of Urbit. Um, and what that means is um, you have like the nodes running the blockchain as Urbit ships. Uh, and the reasons for this are many. And I think it benefits both the blockchain and Urbit as an operating system. Um, but yeah, let me start talking about where we started, where we are now. So yeah, the project got started in around November. Raised some funds, basically all through Urbit, which was really cool. And then I started working on it full time, right then. Um, and we started building a blockchain, a data model for smart contract execution, and then soon after that started putting together the ZK verification system that we now have working pretty well. Um, and there's been some separate pieces and they're starting to come together now. So we have, yeah, there's a Uqbar blockchain. Um, there's a ZK verification system built on top of Cairo, which is a ZK verification language. So Martin Binbex built a knock to Cairo interpreter, and now we are getting started on Cairo jets. So, as most people know, like knock is not performant really on its own, and so you need to build jets which match up to patterns in knock that allow you to um, skip over a chunk of knock execution with a very fast like underlying language. And then that execution gets replaced as like a result. And this works perfectly for ZK proving because in a ZK proof, you really don't care how you got to your answer. It's about getting the right answer, and then once you have like a pathway that got you there, all you need to do is like verify that it works. It's kind of like solving for a square root. Like it's relatively hard to like calculate the square root of a big number, right? But then once you have an answer, you can just multiply that answer by itself, and if it matches the original number, it's verified. So it's like a one-step calculation versus a potentially many-step calculation. That's the ZK verification in a nutshell. Um,
And there's also been, before we dive deeper into the technical aspects, there's
yeah,
also
sorry.
been a number of other projects like Escape that have been coming out as well. Can you briefly talk about what the goal of those is,
Yeah,
I suppose?
yeah. Escape is a basically a groups browser on Urbit. It's basically a fork of the groups app that comes pre-installed on an Urbit ship. Um, and the goal of that is just to have a sort of a DAO OS that's going to be ready once we get the blockchain stood up that will let people perform like on-chain DAO work right in their Urbit ship. So that's one of the cool things about building Uqbar on Urbit is that we're going to give like some cool primitives to Urbit apps. And Escape is hopefully going to be like the flagship one of these, at least built by us, um, that will let people like operate like on-chain entities through like through a very similar interface to what you have today in your Urbit ship. So like if you have like an Urbit group right now in like Escape, you've got like a group, there's chats, there's notebooks. And then long term, like that's going to be expanded to have like a multi-sig wallet in your group where you have a certain permission level that allows you to sign off on various transactions. You'll have a proposals tab where you can vote on proposals. This all would get recorded on chain and like basically a DAO representation, which could also and will also include group permissions to a certain extent. So with a very small on-chain footprint, you can take like permissions and roles assigned to certain ships and have it be automatic group access, chat by chat access. You can imagine like you can do a lot with that.
So would that be what we're typically talking about when we say something like off-chain computations? Or would that refer
Yeah,
more
exactly.
to the ZK style demonstrations? Or
Well,
both?
I guess that phrase could apply to both. Yeah. So on one hand, you have you have on-chain, you have off-chain computation when you run like a ZK verifier that there's post a proof to the chain, like basically a Merkle root of the state transitions, which indicates that gives people enough data to verify that the state transitions are valid. But I mean, I think of that as just that's our execution method. That could be that could be any number of things, but that is a good, scalable, efficient way to do smart contract execution. I think there's another, when I think like off chain, like you know running an Urbit ship lets you take like a very small seed or a small footprint of data that's on chain and then do all kinds of stuff with it. Like if you have an on chain DAO and you have basically just a set of ships and then a set of permissions or roles that are arbitrarily assigned to them. You have leader, treasurer, stuff like that. You take that data, bring it into an app like Escape, and since everybody has this like layer of consensus upon who is what and all that, you can build like a whole group setting where they have access to various apps and various tools within those apps, and they can like construct these like pretty complex organizations around that. Nested DAOs, groups. You can do stuff with like mirroring data, like Orca, across groups in a permissioned way. So yeah.
So this speaks to a long-standing desire on the part of DAO organizers and blockchain developers over the years to have a clean way to talk about identity, ranging all the way from know your customer style regulatory requirements to just being able to, indelibly demonstrate that you are who you say you are. And, this harkens all the way back to old cypherpunk ideas about, if you post your GPG public key, then people can identify you. So I think it fits really well into a way of trying to solve this kind of problem that has been attacked over and over again. Urbit has its own method using the Azimuth PKI, and this is a way of bridging what Azimuth gives you into a functional L1 blockchain. So
yeah.
So I was gonna say, so for those, so Uqbar put out a white paper, they called it a clear paper a few months ago, that described the basic architecture of the system. For those who haven't read that, can you give them an idea of what Uqbar architecturally looks like as a blockchain? Maybe a little bit of how it differs from previous notions of blockchain, and then what it looks like today as opposed to the moment the clear paper was instantiated.
Yeah, absolutely. There have been a lot of updates since the clear paper. So there will be a new one coming out, I think, within the next week or two, and that'll, clarify a lot of the nitty gritty that we've worked out over the past few months. So Uqbar is a blockchain that'll actually start its life as a layer 2 roll up to Ethereum. So a ZK roll up to Ethereum. And the reasoning behind that is that we want people to be able to use their existing Ethereum like digital assets in Uqbar and vice versa. So settling to Ethereum, I think, makes a lot of sense for this kind of situation. but we will still have all of the computation and all of the like data be available on Urbit, and it'll be executed in an Urbit native way. So we won't have to deal with the idiosyncrasies and gas costs and so on and so forth with being on Ethereum native. Yeah, so Uqbar is a blockchain, and I should just say the difference between a roll up to Ethereum and a layer one blockchain is just that we post the settled like state data to Ethereum every so often. So the only difference between becoming like going from that to a layer one is just a matter of turning off that settlement like smart contract on ETH and just rolling on through like as Uqbar. So yeah.
So essentially that's a bootstrap to get the blockchain running.
Exactly.
And then at some point you flip the switch and go over into L1 on Urbit.
Exactly. Eventually, we become basically standalone, self-sufficient with financial assets and stuff, So yeah, Uqbar is designed as a ZK blockchain. So there are some. It's like conceptually like a little different from a blockchain that everybody needs to run the same computations, but we still have a lot of the same like basic like architecture and terminology as a like a standard smart contract blockchain. There is a main or like relay chain where every validator is a part of this, global consensus within Uqbar. So you see all of the new blocks that are posted. You have one block every 15 or 30 seconds. We haven't, we're going to optimize it for like how fast it can go, but that's not quite, ready yet. But you have a new block posted. Blocks are ordered into epochs, which are like longer periods of time. And you have epochs because that allows you to have like a set point where you can do something like roll up to ETH. You can add new validators, sort of like have this like point where you can like say, okay, here's a new set of validators or a set of new shards. Because in addition to this main chain, you have shards. So computation occurs on shards. We call them towns. So towns will have a set of sequencers. Sequencers are kind of like miners in a proof of stake blockchain or a proof of work blockchain. Sequencers are the people or the ships, I should say, the Urbit stars who execute transactions which have been posted to them. And then they produce a chunk which gets included in the next block. So blocks are made up of state transitions from all the shards that are active at that moment, who have their own set of sequencers. So this is like a pretty like modular, scalable way to have your blockchain set up. Different towns or shards. I use shards because that's sort of like the standard terminology in the space.
Mm-hmm.
So I think that's what people will resonate with. But this allows you to have like, different sets of sequencers with like somewhat different like use cases. You can have a group that's focused on speed, at the cost of centralization. You have the standard blockchain trilemma stuff at that level. Speed, security, centralization, and so yeah, you have these multiple shards like operating, and then you have a main chain which posts all these blocks, and that's sort of a data availability situation where you want to have like basically you need anybody to be able to validate the state transitions posted by sequencers. And so that's what the sort of main chain blocks are for. So that's why the people running that are called validators. So that's the basic architecture. Yeah.
Classically, right, we have proof of work and proof of stake blockchains they're both trying to solve what in short we might call the double spend problem. Like that's sort of the fundamental problem, is making sure that the associated information, the coin, the smart contract knowledge, whatever it is only used once in a legitimate transaction. How does Uqbar solve this problem?
Yeah. So We've been calling this like a proof of identity blockchain, but proof of identity is like relatively similar to proof of stake in a practical sense. Um, However, I think even beyond the like proof of stake, proof of identity, proof of work description, I think the ZK verification is the most important detail here, because in a traditional blockchain, in order to solve this double spend problem, you have every actor or every node, every staker individually run through the transactions or the state transitions occurring in each block in the chain. And they come to consensus about the state transitions by producing their own version and comparing it with those of other people's. And if there's a disagreement, you go through this forking mechanism, and there's game theory involved to make sure that at least 51% of actors are on the same page as to what's going on. In a ZK verification context, this changes, because what you're actually producing as when you go through the transactions or the state transitions is a proof of the new state. So you calculate a new state of the blockchain, and you post a proof of that, and other validators can look at that proof and very quickly verify it. So this goes back to what I was saying about that square root problem. You know, calculating the square root of 49, you have to maybe go through some steps. But once I tell you it's 7, you can simply multiply 7 by 7. And say, oh, that's 49. So that's a valid transaction, or that's a valid calculation. So in a ZK verification context, you only need one node to run through that original calculation. Then everybody else just verifies it. So to solve this double spend problem, you just need to make sure that that data proof is available to everyone. So that's sort of like, yeah.
What does this mean in terms of the relative privacy of transactions? Right, like we're not I don't think we're ending up in a Monero type situation where it's fully anonymous, even if we're working with the ZK proofs and just posting the hashes, etc.
Yeah, that's correct. I mean, to create like a privacy coin, you would have to do some extra work around anonymizing like incoming transactions and addresses on the chain on which things are stored. But I think ZK proving often gets labeled as a privacy mechanism, when in reality, I think it's most useful for scalability and like low cost of operations, because you don't need to add these extra anonymization mechanisms. All we're really interested in at the moment, at least, is building a scalable modular blockchain, that allows people to cheaply involve themselves in it as either a validator who just looks at state transitions and verifies them sort of passively as they see new blocks, or as a sequencer who actually orders these transactions and creates a proof. So those are both like relatively like low cost operations compared to like a traditional blockchain. There's a lot. It's a much smaller demand, when it comes to computational power. So it's a lot more efficient, and I think it'll allow for more speed and scalability as we grow.
So my understanding is that the role of a sequencer is intended to be played by stars. Is that correct?
Yes. Sequencers and validators, basically any top level operator in Uqbar, will be limited to Urbit stars. And this is where that proof of identity mechanism comes in. Stars are scarce and valuable just in their own right, which creates, first of all, it creates an incentive not to burn them. You can't burn an identity like a star, at least not cheaply. This is very different than participating in Ethereum or some other blockchain as a miner, because there's really no identity mechanism there that isn't like burnable. You can jump on the network as a different IP address or something like that. for free. So there's some stake involved there by just staking your identity as a financial like loss, but there's also an aspect of like iterated participation that is really nice, because right now all blockchain game theory concepts have to be like one time game theory. Like there's no iterative play. There's just it's a one time interaction. So in a lot of traditional game theory problems, you have like that is usually a situation in which defecting or not cooperating is just more advantaged. So in an iterative sense, like when you have a permanent identity that you can use as a participant in the blockchain, it's a lot easier to encourage good behavior. Now, that would be really important if we were doing a traditional, everybody runs the same calculations, we need 51% consensus. But actually, in a ZK verification scheme, the game theory stuff is not that important. I mean, what's amazing is we've been able to like totally elide those complicated human problems and replace them with mathematical proofs. So that's what's really great. But that being said, the proof of identity stuff will allow for more subtle, fine-grained treatment of problems like transaction censorship and MEV, things like that.
Is there liable to be a scaling problem with a finite number of stars on the network?
I don't think that will be a problem in the immediate future. 65,000 stars is a pretty good amount. And I think that will be more than enough to provide like broad validation and sequencing. I mean, that's a lot of nodes to run a network. That's more. I mean, imagining all stars as Uqbar stars. It's more validators than any blockchain has at the moment, I think.
So there have been a couple of related questions that I think it makes sense to inject here. The first one being, are sequencers remunerated? And the other being, how are gas fees calculated?
Two good questions. Yes, sequencers, of course, will be rewarded by mostly gas fees. I think that some of that like some of the details around how Ukbar like will remunerate sequencers and validators has not yet been worked out, but that's definitely necessary, a reward for participation, even if it's just transaction fees. So that should be considered as similar to other blockchains. And as to how those gas fees are calculated, that's something I've been working on very specifically over the past 2 months, and we've built a contract execution engine that's in a pretty good state right now. It functions really nicely. So what we had to do there was produce a bounded knock interpreter. For those of you who are like, Hoon programmers, there's already a knock interpreter. There's already a virtual knock interpreter called Mule that you can just evaluate some knock in. So producing this bounded version was pretty quick, because all you need to do is at every step of the knock tree, just assign a gas cost to that step. And since there are so few opcodes in knock, that's not too bad. We'll do some practical calculations as to like how much computation exactly it should cost, but yeah, that's basically it. Yeah.
A related question then is, how does Uqbar address the halting problem? How does it calculate gas without infinite loops?
Yeah, so I think no blockchain has. I mean, if they solved the halting problem, they'd be very famous for that, right? But the solution here is just to have a gas budget for every transaction, and if you run out of budget, your execution stops at that moment. So when you submit a transaction to a contract of any kind, you submit it with budget, and if you spend all of your budget, you spend all your budget. It's over. So that's how you resolve an infinite loop in the execution.
Okay. So, kind of segueing into the next part, can you talk a little bit about the actual developer side of Zock and what is written uHoon and has a variety of competing pronunciations, just like BitTorrent?
uHoon.
That's my
Yes.
preferred. I won't insist on it, but talk about that a little bit and
Yeah.
what the smart contracts and these sorts of things look like from a developer standpoint.
Yeah, absolutely. I'm excited to do that. I'm really excited to get people like onboarded to like writing smart contracts. So Zock is just zero knowledge verified knock. So that's the term we've been using for that. Um, and then uHoon is the version of Hoon which is used to write and execute smart contracts. And it's very similar to Hoon. I mean, syntactically, it's just Hoon, but the difference is that in the smart contract execution environment, you have a limited set of standard library functions and jets, which are used to run the Hoon. And then you also have some additional standard library functions and types, which are used for writing contracts. You know, a contract is a type in uHoon. It's a type that your contract has to nest under if you want to publish it to the blockchain. So stuff like that is part of uHoon that I think people will be getting familiar with soon. But yeah, it's really nice. It's really nice to write smart contracts, and this is something I've been doing like basically whenever I have free time. It's just like trying to write more smart contracts, and I can share what one looks like right now. I can like share my screen and maybe use that as a backdrop for this. Um, Now I'll note that, you know, there's maybe some changes that'll occur between now and this being something that you, the viewer, is going to write. But this is the contract for our token that would be the gas payment token that a transaction might use to spend. So this is like similar to like just a standard ERC20 token on Ethereum. Um, and this is what the contract looks like. So you have a door, it takes in a cart. A cart holds some state that gets added to every contract call. You have ephemeral memory. You have the pub key ID of that contract itself. You have like block number. You have the town or the shard that you're operating on. You have a set of data that you own. Oh, look at that. The little toy blockchain that I'm running in two fake ships here just had a some sort of subscription disconnect. So they'll have to catch up to one another and get back in their uh, you know lockstep. Yeah, it's kind of fun to watch. So these are just running on the side. Um, so yeah, back to contracts. The most important thing to know about Uqbar smart contracts is that our data model totally separates data and functions. So this is kind of in the ethos of Urbit as a purely functional OS. We have purely functional contracts. So this contract holds no state of its own. It is a bundle of pure functions, and state is passed in with a transaction at execution time. This allows for like really nice parallelism. You can execute contract calls in parallel if they don't touch the same data. It also allows for like pretty clean contract writing, and it allows for less contract duplication as well. So, for example, if you want to publish an arbitrary token on the Uqbar network, you don't have to write your own contract necessarily. Similar to how Ethereum has like the ERC20 token standard, the ERC721 NFT standard, those standards in an Uqbar context can actually be fully functional smart contracts where producing a new token that comports to that standard is as simple as issuing a transaction to that contract. So right here, I have this fungible token standard contract. It's got the following arguments. It's got give, send tokens, take send tokens from an account which you have an allowance for to another account. You can set an allowance for your account. These are sort of standard to the ERC standard or just general crypto token standards. But then you also have mint and deploy. So deploying a new token with the following characteristics is a transaction to this contract. And then minting tokens is also a transaction. And you can handle like, you know, 1 million tokens through this one contract because the tokens are all just stored in data chunks on chain. So I also have the data chunks typed out here. These are the molds that
are contracts versioned?
At the moment, there's not a versioning scheme here, but we are definitely thinking about how to do that. It's an interesting question because, of course, on Urbit, we want to go with the Kelvin versioning scheme potentially, right? Which would be pretty cool. Yeah, so there's contracts can be deployed and then upgraded, and so by default, that would just be like versioning them 1.0, 1.1, you know, so on and so forth. But a Kelvin versioning scheme would definitely be interesting.
I will also never tire of pointing out to people how the standard structure that you're able to do, similar to what you see with Gall agents, but just using cores in general, makes it so much easier to write and structure these kinds of programs using Hoon.
Yeah. Yeah, people who are familiar with Hoon will be able to very quickly reason about what this piece of code does. They'll be able to see this door, and there's a write arm and a read arm, which I'm not using in this contract yet. And then within the write arm, you have a core, which the top level code is immediately executed. And then every arm beneath that is just either a data mold or an actual execution arm. So yeah, state and functions are totally separated. So to write a contract, there's a little more legwork to be done around bringing in your data, type checking it to see if what you've dragged in from the chain matches what you want in the contract. And then once you have that, operating on the specific items within that piece of data. So a token account obviously has a balance. That's the main thing. It also has a metadata ID, which tells you what kind of token this account has. And this is all secured through these pieces of data being published on chain with this contract as their only modifier. So you have a piece of data which has a account or a pub key which indicates who is capable of modifying this data. So with a contract like this, the only modifications possible are, you know, permissioned by the contract. So you have like the give arm or the give argument here. When you take a give call into the fungible contract, you grab in the grains. That's kind of the euphemism we use for data stored on chain. You match it to the type of account you want, and then you walk through the logic. You do some checks, and then you switch the balances. You know, you subtract it from the giver and you add it to the receiver, and then you issue the modified forms of the grain that you used. Yeah.
So to be clear, this contract that we're looking at here is written in contract optimized Hoon and would be running in Zock on the blockchain. And to interact with it, we would have a traditional Gall agent that is triggering these events.
Sorry, can you say that again? I just want to make sure.
So this code that we're looking at right now would represent what is actually running in Zock on the chain.
Yes.
And then we would have something like a Gall agent that would be interacting with this contract running on our own chip, and then that's interacting with this running on chain.
Yes. Essentially, that is a compiled contract on chain. And to interact with it, you issue transactions through a sequencer. Yes. And your transactions are sent over the Urbit network pretty directly. So you would talk to a sequencer star, submit your transactions to it, and see them processed on chain. Yeah. We have a wallet agent. So we're working on a pretty basic like Uqbar wallet. That's a Gall app. But eventually, there will be many ways to submit transactions, both on and off Urbit, probably. Um, yeah.
A couple more questions that are worth injecting at this point. One of them is, how do you handle jets, in particular with errors in jets and how that interacts with consensus?
Yeah. Yeah, so the Uqbar jets definitely have a higher standard of like correctness, I would say. I mean, that's definitely important. Um, our jets are written in Cairo, and the set of jets which will be available for use in computation will be probably limited by their auditing or their audited state. So that, yeah, the same thing applies. Um, that being said, if like in terms of consensus, if there's like some validator or some sequencer using a malicious jet or something like that, their state transition would be flagged as no good by other people using correct jets. But yeah, achieving jet correctness is definitely like a tricky problem, and we'll have to carefully audit that stuff. That's not what I work on specifically, so I might be missing a detail there. But yeah.
So another question is, will the zero knowledge tech help prevent the need to fork the chain?
Yeah, there's a lot less reliance on game theory aspects of blockchain, like forking. There's the idea of like a 51% attack doesn't really make sense under this context, because all it takes is one invalidation of a proof to make it pretty clear to observers that a state transition wasn't um, done correctly. Yeah.
What about how contract state is stored? What's on chain versus off chain, for instance?
Yeah, it's funny because I was like gonna say, it's like there is no contract state. There's just the functions. But yeah, the contract itself is stored as knock on chain. So it's compiled knock, and you can produce that compiled knock from any Hoon file. Um, and specifically, our contracts are compiled against the same subject. So when you produce the knock, you're not producing it in a vacuum. You're producing it as a battery against a payload, which is always going to be the same. That payload contains uHoon. That's exactly what's produced every time. You have the uHoon like knock, and then that gets like the contract knock gets compiled against that, and then you just store that knock on chain, and it's like a very small amount of code. It's measured in bytes. Very easy to store. Yeah.
Well, shall we talk a little bit about parallel contract execution, which is more your
That'd be
forte, as I
interesting.
understand?
um, I hope so. Yeah. Yeah. Like that's something that like we haven't like built like parallel execution because we're still building like the blockchain core. Um, but everything we've done has been designed around making that really easy, and I think it is going to be really easy. Um, so we have state, we have functions. Each piece of state data on chain is like labeled, curated, like has the contract which has provenance over it, like carefully labeled. So creating parallel contract execution is just a matter of ordering these transactions in a way like this is like I think the term is like it's an embarrassingly easy parallelization problem. Like that's the official term or something. And then because all you have to do is just like say, oh well, these two contract executions don't touch the same data, we can do them at the same time, and it's like easy as that. um, and then the other detail you need there is to execute all of the contract calls against the same state. So you take the state at the beginning of the block, and all the contract operate against that state. This includes the time at which that happens, because as you know, like we're like, well, you might not, so that I should explain this. Contract reads are just scries. So you can, within one of those contracts, scry out to another contract, which is pretty awesome. But to get the state correct, yeah, you freeze time at that beginning of the block moment. All scries happen against that period in time. All executions happen against that state, and then you come up with a new state. And then of course, some contract calls involve chaining multiple calls. So you might have a contract that wants to call out to another contract after changing some aspect of like state. So that's possible as well. And that just happens in the next batch of like parallelized executions. Yeah. Does that make sense?
Yes. A couple other questions here. Could stars delegate validation to one of their moons? So sort of open-ended. Yes. What will delegation look like?
Yeah. Generally, yes, for sure. We need to have stars capable of moving computation off of like their main ship. So this is like, I mean, the simplest thing, the simplest part of this is just in like the sequencer Gall app, just running checks that the other sequencers you're talking to are either a star or a moon that's run by a star. But you can go further than that too, and we'll definitely have like, I mean, this is one of the things that's just like so easy with Urbit, right? It's just like, oh, like what kind of identity are you? Like who's sending me this, and what's everything about them? Who's their parent? You know, so you can find out all that kind of stuff. You can limit how many moons each star can run. All that stuff is like super easy with Urbit. You know, that's like the main advantage. That and like the fact that we can build stuff super fast in Hoon.
Mm-hmm. So there was I think I want to circle back around to a bit more of a philosophical question, which is, it's been pointed out that, you know, with proof of identity as solving, or, you know, with finite identity as solving the Sybil problem, and proof of identity as solving the issue wherein you're trying to identify the source and nature of a particular transaction, and you're able to do it in a stateful way because of the Arvo event log. Is this going to open up new ways of thinking about the fundamental problems that proof of work and Bitcoin were trying to solve when they were first introduced?
Yeah, I mean, it's definitely interesting, because I think proof of work has its own benefits as it applies to bringing real world energy into a, you know, a digital like space of like proving something. I think that's hard to replicate, you know, in any sort of like, when you have a digital identity, there's still like a fundamental problem of like, what does this connect to as a physical asset, you know, where proof of work has like this very clean connection between real world energy and then like whatever you're trying to do in a consensus state. So Urbit ships, like, yeah, I mean, it gets you halfway there really quickly. You know, it gets you into that persistent identity state really quickly, which like now I come to take for granted because I spend all my time on Urbit. You know, everyone has a persistent identity. But like, I don't know. There's definitely still in my mind like a world of like proof of work at bringing benefits to a blockchain. And you know, I think just to say like Uqbar as a project, we have no ideological you know, position around the various like ways in which you can put together a blockchain. All of our like decisions have really been with the goal of like taking like all like the prior art. Like this is what like Timluck Miptev would say here. It's like, you know, taking the prior art of blockchains that have shown to be really useful to people, and then just like doing the best version that's been done in the space and just bringing the best solutions together. Timluck Miptev is the person, like, you know, really putting together Uqbar. It's great
architecture
guy.
Yeah. Awesome. Well, let me check. I think we have pretty much run through our questions here. Oh, here's one that I think we haven't hit. I don't know what zinc is, so I may be enlightened, or this may be a Dr. Seussical question.
No, it's a real question. It's a real question. We have a zinc, which is like so I'll explain like the etymology of the term. So you have like you have mule, which is like virtualized knock interpreter. Then you have mink, which is like a special version of mule, which is like slightly different. And then you have bink, which is like bounded mink, you know. And then zinc is bounded virtualized knock execution that's in a ZK like verification context. So that's zinc. And then Zock is just knock that runs on the Cairo engine instead of the C jet engine or the Veer runtime.
This is starting to feel like Cockney rhyming slang.
Yeah. Hoon gets there for sure. I mean, maybe you noticed in my like contract code that I was sharing, there's a lot of like farm metaphors. So Logan, Tackrite, Socrep, and I, when putting together the contract execution engine, we call it mill. So it like processes grain. Grain is like on-chain data. You run grain through the mill and you get a new granary, which is the chain state. But that's just for fun. I mean, it's really nice for me, actually. I should say it's not just for fun. It's really nice. Metaphors are very important in writing code, I think. And you have to find a good one that's very easy to understand, but does evoke what you're actually doing, in an abstract sense. Because otherwise you end up with a million like contract execution unit 1, like contract input 2, contract output. Like you have like these names don't really help, with understanding.
Right. You end up in a situation where you basically have 3 possible approaches. You can do the full enterprise API, like you just mentioned, where you have these enormously long names that kind of get at what's happening, but do a poor job of differentiating subtle differences in roles. You can have basically metaphorical names that are shorter but require you to fully enter and inhabit the metaphor to accomplish what you're trying to do. Or you can have nonsensical names that are designed to shake you out of thinking you understand what's going on before you do it. And obviously that third is much of the Hoon standard library in many regards. But I am seeing a lot of the newly distributed code that's been coming out since Grid in the fall is using internal metaphors to describe a lot of what's going on.
Yeah, I hope it catches on as sort of a standard. I like it. I think it's a good middle ground because I hate those enterprise names. They get really long, hard to type, and then you have like literally like versions of the same thing, especially in like a fully functional language, because I feel that a lot of times you'll have like a type union, which is like there's 3 potential things that can come out of this piece of code, right? And then to differentiate between those 3 things, you need like 3 separate terms. And if you're going with the enterprise path, like very hard to come up with. But in a metaphor, you can use synonyms, very clean, very clean. Yeah.
All right, I think we're through questions. I think we've got a pretty good idea of now what Uqbar does. And I, for one, am particularly excited to see Zock, jetted Zock, contract optimized Hoon, and smart contracts in practice. And that was fantastic to see the actual code that you had there. Yeah. Anything else you'd like to add before we wrap up? And then everyone is invited to come to the Google Meet discussion that we'll post here in a moment.
Yeah, I'll be hanging out in there for a little while. So yeah, I mean, I apologize. I find it hard not to sometimes like ramble because there's so much going on. I mean, it's like pretty wild. I'm very proud of like, we've been like moving very fast and stuff. And I think hopefully, I think this summer, definitely, we're going to have some really cool public testnet stuff to show people. And since we have like we're all friends hanging out on the Urbit network together, like there's no barrier. Like, you know, you can download this app on your Urbit ship. I mean, you can download it right now if you want to. All our GitHub repos are public and stuff. And, you know, here I might as well link those, right? Like, let me just pull it up. We have like these public repos where you can like look at this contract code, and, you know, I'm not gonna, you know, it might be tricky to figure out what's going on, and, you know, we're not ready to start walking people through that step by step yet, but it's all there, you know.
Yeah. All right, I will drop that in the chat window there. I also just dropped the Google Meet link for the chat after this. Next month, we'll be talking with James of Twan about the groups refactor and some of the changes that have been made there. Get an update about what that involves and what that feels like. So, you know, if you've been interested in landscape and the evolution of groups and the entire front end of the Urbit experience, then watch for that. And otherwise, we'll continue to investigate what's going on inside of all these wonderful Urbit projects. So, see you in a few minutes in the Google Meet.